Brent and I go back a long way, but I won't tell you about some of the experiences we had together years ago. Tonight, we're going to talk about one question, and that is, were humans in the Western Hemisphere before the people that made points like this arrived? And I'm not going to try to influence you too much, but I did bring some artifacts from the site that I'm going to talk about. And I called them artifacts. I should say specimens, because you may not agree that they are artifacts. Now I'm going to have to look at these notes a little bit here. I don't know if you're going to be able to hear me. Can you hear me if if archaeologists use stratigraphy, typology, and dating methods to determine relative or absolute chronology, should archaeologists ignore sites when there is little or no undisturbed stratigraphy, when no diagnostic artifacts are present, and when conventional dating techniques such as radiocarbon dating cannot be applied? So I'm going to address this whole issue from the Container Corporation of America site that I excavated back in the mid-1970s up to around 1980 or so, and then what we've been doing since the beginning of the 21st century. The site is located in an area of extensive chert outcrops in north-central Florida, and quarry sites provide unique opportunities and also stone workshop sites to study temporal changes and cultural differences in stone tool manufacture, and also the sites endure through time. And there's an abundance of material at these sites because humans tend to be very wasteful. Now this shows the stratigraphy at the site, and actually the stratigraphy throughout most of north central Florida, where you have limestone peeping up there at the bottom. That's probably Ocala limestone, probably dates to about 60 million years old. Above that you have the Hawthorne formation, that sort of blue clay, and then above that you get into late Miocene, Pliocene, and early, middle, and late Pleistocene, and the whole area is terminated then by sand cover of various depths, with maybe a little bit of vegetation as modern deposition. I surveyed the CCA site and placed excavation units several places before settling on Area 3, where we dug 5 3-meter squares. And I'll tell you about why I did that in a few minutes. Here's a map of the site, and let's see. We used to come in here on Johnson Lake Road, and right here is the old Johnson Lake site. As some of you that are as old as I am may have read about that, written by Ripley Bullen in 1959. And he found, essentially found early and middle archaic materials there. And there's a really wonderful publication out from 1959 in the Florida Anthropologist. However, some of the locals have told me that as early as the early part of the 1800s, when Americans first went into the area, that people would go there on picnics, and that site was literally potted to death way back in the 1800s and early 20th century. Anyway, we surveyed in there and then all the way across here, put excavation units in here by Duck and Doe Pond, and then some excavation units in here. And then on over here in what we called Area 2, which I think still has some potential for what I'm going to be talking about tonight. But then we settled on Area 3. Now, anyone that has ever been to a quarry site or a workshop site is struck by the mind-boggling numbers of broken stone. And I would like to say that probably 90% of the world's people would look at that stone and not be particularly interested in it. However, certain features pop out at me after years and years of looking at this kind of stuff, and I could tell you by looking at that this stone was struck by people, that there are negative and positive modes of percussion, that there are numerous flake scars, secondary and tertiary flake scars on the surface. Some of these flakes could actually have been struck from that core. The core itself could also be a tool. And so there's a million things that you can tell by just looking at those remains. However, you're probably at a workshop site not going to find very many formal tools. And you're certainly not going to find things like this beautiful array of stone points from Florida. If you did find some diagnostic tools, they'd probably be broken because you're not going to leave them at the quarry site. If you make them, you're going to take them somewhere else, probably. So what you have to do is you have to sort of depend on technology instead of typology in order to interpret the time periods that you have at the site. At the 3 or 4 quarry sites that I've worked at in Florida, the primary points that were probably being made were early and middle archaic points. So from, say, 9,000 or 10,000 years ago, they keep pushing the archaic back, up to, say, 5,000 or 6,000 years ago, you'd find the major amount of broken points. Also, you see another major technology being introduced, and that's thermal alteration, and that's why all of these points have turned pink and vitreous. And people learned that when they heat altered carefully some of their flint material, they could flake it easier, and also it was more beautiful. Now, getting back to what I'm going to talk about tonight, I'm going to spend the rest of the time talking about Area 3 here, and because of the interesting things that we found in that area. Now, I apologize for the color loss after about 30 years. So not all of the slides are like this, and if I were a photographer or a film expert, I might be able to explain it. But nevertheless, that all of the diagnostic artifacts and everything were found in the sand component that overlies the whole area. The early points, the paleo points, were found at the base of the sand, just where you start to get into some rubble. Here is, and by the way, I brought almost all of the tools that I'm going to be talking about. I brought with me, so you can look at them and determine whether you think they're really tools or just broken rock. This little unifacial scraper came at the bottom of the sand. It looks exactly like a Upper Paleolithic scraper from Europe. You could, in fact, stick it into an assemblage of Upper Paleolithic tools, and you would never know that it had been intruded. Here is the broken, it was probably broken in the process of manufacture, base of a Swanee Point, which is Florida's early Paleo-Indian. And it was found right at the base of the sand also. And if you look real hard there, you can see some little concretions coming in, and that sort of signaled the bottom of the more modern deposit at the site, and in fact all over north central Florida. We scraped the square, we scraped all the square sort of level, and we're not going to go below that to excavate because we had all been told, oh heavens, you don't want to ever excavate below the sand because you'll get into Miocene deposits. And so we decided anyway that we'd go ahead and put some post holes in. And you can see the post holes there in the middle of the square. And lo and behold, now here's something you can't make up, and I'm telling you, we weren't looking for it. We didn't suspect it, and never dreamed we'd find it, never thought of it, never heard of it. We went down about 20 centimeters into the sandy clay deposit below the sand and found this pick. And we felt obligated then to take all of the excavation units down lower. I don't know if you can see that very well, but there it is in place down there, and it's just another shot of it. And here I am over 30 years ago, standing there pointing to the stone that comes down. You can see how far down it is in the unit. Here's a little bit better picture that shows the sand there a little bit better. By the way, this is Nina Borman. I cut her head off of this picture, but some of you may have remembered Nina from way back, and I'm not really sure what she's doing now, but she was a heck of a good field archaeologist. And there's some more of that stone peeking up. You can see how far it is below the sand deposit. Everybody, I mean, we thought we were crazy, so we got Dr. Tom Hallmark, who was a soils characterization specialist at the University of Florida, professor, and he came out and he identified what he called 2 lithologic discontinuities, and that indicated to him that there had been a long time surface exposure of some of the sediments before other sediments were deposited. And later on I'll tell you about what we're doing now, or what we just did in 2007 at the site, that in a way sort of bears out his Tom Hallmark's findings. Here's a sequence just showing the differences in the coloration as we go down. You can see the white cover sands up there on the upper left and getting progressively darker and darker, and then into the clay on the lower right there. And now I'll just show you a series of some of these stone objects. At this one, you can see the nature of the deposit that was found in. But here, I don't know if you can see it distinctly or not, but it's a beautiful blade scar that pops out at most people. Now, that doesn't mean that Mother Nature can't occasionally break stone up herself so that it looks like an artifact. Also, you can't tell, but you can see it on the specimen I brought, that this is broken off at the end. So it actually came to a point, and the broken area almost looks like it had been used as a pick or a chisel or something like that. We know that happened in antiquity because the coloration is exactly the same. The other thing to notice is just how smooth this surface is, because in a minute I'll be talking a little bit about weathering and talking about smooth surfaces and rough surfaces. It's also a neat fossil there. Now again, unfortunately, the color loss has sort of diminished the importance of this. This particular specimen, you're looking at the ventral surface of this specimen, and it is very similar to a type that was actually described about 50 or 60 years ago in the literature for the southeastern United States by people who, at that time, believe it or not, were postulating exactly what I'm talking about tonight, that were people here before you had these formal artifacts. By the way, that style, that sort of nose, they actually called it a nosed scraper, and you can see that on the one I brought. And here's another one, again, showing the nature of the deposit. Here's one that came from 132 centimeters down, and I myself was dubious about this one, and I still am dubious about it. But if you look at this, the cortex, the geologic cortex has been completely removed from the specimen, which seems a little odd if it was worked by Mother Nature. Now I'm going to dwell on this for a second here, because this is sort of an important slide. There's no doubt that specimen came from that gooey sandy clay. You can tell by the shoes on this person over here that they're standing in it. Also, the sand up here, which was about 60 centimeters thick, has sort of eroded off because it's so friable. But in that square where this specimen was found, we also found in the sand, quite a bit up here, a Kirk-serrated point, which is archaic, early archaic, and probably should date about 9,000 years. So when I start talking about weathering, I'm going to refer back to that specimen a little bit. Now here's the specimen. I want you to notice a couple things about this specimen. It's the same one I just showed you, only we took it out of the dirt. And whoops, I can't go back. Notice the roughness of the surface here on this specimen. And when I start talking about weathering, I'm going to mention that rough surface again, so try to remember that. Now here's a lab shot of that specimen, and you can see it looks like a big gouge of some kind. I see use wear in there. I also see that there's no geologic cortex on that specimen, and we were going to do these weathering studies, so what we did was we sawed that specimen off right there to do some weathering studies so we could see the cross-section of that specimen. So we did the weathering studies. They were based on surface chemical and structural changes. They were conducted by the Material Science Engineering Department at the University of Florida. And we made the following assumptions in doing the weathering studies on the stone. And whoopsie, well, the first assumption, I'll tell you what it was, is that people are going to use fresh stone to make their tools. I think you'd probably all agree that that makes sense. The second thing is that the stone that you find at a quarry that's been worked is probably going to be from that quarry, because if you got tons and tons and tons of stone there, you're certainly going to be using that stone. There are exceptions to that, but they're pretty small. The third thing is that the same excavation unit, wherever you're finding your materials, will have been exposed to the same type of environment, depending, of course, on the depth. So because of 1, 2, and 3, various degrees of weathering should reflect a difference in age. So here we have a specimen that was found in the sand over here on the left in almost the same position as the Kirk-serrated point that I just talked about. And over here on the right is the specimen that I told you that we sawed the end of it off. Now here you can see this specimen is virtually unweathered after almost 9,000 years. This white here is not really a patina, it's part of the cortex that remains on one of the surfaces. The specimen over here on the right has undergone both static and dynamic weathering. The static weathering is when there seems to be a complete breakdown in the silica bonds, and the dynamic weathering is when you have the leaching out of certain ions. Now that's way over my head if it's over yours too, but I think you can see without a doubt the static weathering causes a roughness of the surface, and this actually underwent some kind of weathering even in the middle of it, like a static weathering, because the specimen is just so dried out looking. If you look at how moist that nice fresh specimen is there. The patina formation is this white around it. Now, we had literally hundreds of specimens that had only dynamic weathering. And those are the ones that we sawed and used for our experiments. The material science engineers used for the experiments. And what they did was they took the average thickness of the patina from many, many different specimens, and that is what they based their dates on, and they based it, the weathering, the rate of weathering, as compared to that 9,000-year-old specimen that is barely weathered. I hope you're understanding what I'm talking about. They did not use the corners of the patinated specimen because the patina tends to gather there in the corners, and that sort of sets that average off. Okay, the results of the weathering studies and subsequently thermoluminescence studies that we did return dates of 25 to 28,000 years for the crude tools from the lower stratum. And I'll get on to in a second here and talk about the TL, but I want to say something about why we did the weathering studies and how I was able to interest the material science engineering department at the University of Florida to look at my lowly stone from my site. They were under contract from the Department of Energy way back in the 70s to try to find the best burial, storage, or encapsulate material for nuclear and toxic wastes. And so they were sort of interested in the fact that I had found this really, really weathered material, stone material, thinking that the composition of that might be a good encapsulate material for the nuclear waste. I cut out a editorial from the newspaper about 2 weeks ago, and would you know that this whole problem has never been resolved, that all of our toxic wastes and everything that had been in storage for all of these years is still sitting there waiting to find the proper burial location. So even science does not move that fast sometimes. So. Okay, TL now is there's trapped energy in certain minerals. Chert material has luminescent properties, so it would be a good material to use. People have used thermoluminescence for ceramics also. So you get trapped energy in these minerals, and it's released when it's heated, either intentionally or accidentally. So if you intentionally thermally alter material, like some specimens I showed you a little while ago, that would release the energy, and then it starts to build up again from that point. Then on the old materials, of course you wouldn't have intentional thermal alteration because they weren't doing it that far back, but they would have fires, and just a 350-degree fire or even less will blow up the flint, and probably enough to release the energy. And so you set the TL clock to 0, then it starts building up again. And that's what we based our dates on. Now, I'll let you look at this slide. Don't bother reading it, but those are the steps that we went through in order to get the TL date, a pretty complicated set of steps. But I wanted to tell you a story about how we got into TL. And in the 1970s and 80s, I belonged to a wonderful organization called Archaeometry. It was an international organization. It was composed of physicists, chemists, and geologists, and anybody else that you can, all kinds of engineers, and for the sole purpose of working with archaeologists to try to solve some of the problems about antiquity that we could not solve any other way. The people at Oxford University were doing a lot of research with thermoluminescence, and one of the products of that school moved to St. Louis, Missouri, to Washington University. And David Zimmerman was the one who did the TL dates from our specimens at the container site and came up with the date 26 to 28,000 years. And this was independent of what we did with our weathering. It was completely independent. The people at WashU did not know about what the material science people were doing. David Zimmerman died tragically. He supposedly got hit in the eye with a tennis ball and it killed him. And we just felt horrible about that because we were in the process, we thought, of getting some good results. But so when he died, I figured there wasn't anybody else in the Western Hemisphere doing TL. So I decided that maybe we ought to start a lab at the University of Florida. So I was able to get money. I set aside part of my lab area, and we established a thermoluminescent dating facility. And had a postdoc, Dr. Chris Maurer, from material science engineering, and geology and material science engineering helped with our work. Well, I thought we were getting pretty good results, but you know, you can't have a controversial topic with controversial materials and expect to get money. So people, even at the National Science Foundation, called some of the stone I showed them rubble. And so I just decided to heck with it and started doing something else until the 21st century. So thanks to Mr. Bill Whitehurst, who's the present owner of Container Corporation of America. And by the way, his family was in that area for over 100 years anyway, but and they own land surrounding the original site. So when the Container Timberlands decided to sell the property, Bill Whitehurst took it over. And he has been most generous in furnishing equipment and help and personnel so that we could do some of these recent studies. We first started out in 2001, and Bill put in a backhoe trench for us. And you can see here the bottom of the sand, and then you can see the sort of hard pan layer here. And about where my hand and the trowels are is where we had found the materials back in the 70s, just about that depth below surface. And then in 2006, and I think you read, but I should mention, some of you probably, in fact all of you probably know about Al Goodyear's site up the Topper site in South Carolina. Al Goodyear was one of the scoffers back in the 70s, but my site, but when he began to find stuff at the Topper site, he became very interested in the container site. And so Al and I went back in 2001 and then again 2006 and opened up a whole bunch of trenches. And then in 2007, Dr. David Lee, who's a soils morphologist at the University of Georgia, came down and worked with us, and you can see how beautiful a profile he's exposed there. He just really got it scraped down so you could really see what was going on. We also mapped the site and plotted in where all the trenches were. And now you want to look specifically here at trench 8, because that's what I'm going to talk about just about the rest of the time here. In trench 8, Dr. Lee found a buried gully wash here. He called that the lower fill, and then the middle fill, and then above that were the more surface deposits. And now keep an eye on where those little yellow lines are. And so he decided that we would do some optically stimulated luminescent dating. That's called OSL. And so the little round circles are where he took the OSL samples. And then he also, the beauty of the thing is he found some artifacts. One here and here and here. And by the way, also, I'm having trouble seeing this a little bit, up right here in the sand deposit, the cover sand deposit, we found another Kirk serrated point that we had used for our weathering studies earlier on. Because this OSL sampling is pretty expensive, we decided that we could only try for 2 dates. So we took sample 2, and I think it's sample 5 there, and submitted it to OSL dating laboratory. Now the samples are taken very, very carefully. What you do is you drive an 8-inch plastic tube that's about 1.5 inches in diameter into the wall of your sediment, and then you only use the portion that is protected in the middle of that 8-inch tube, and that is to keep, of course, from contaminating it. We got some really encouraging results to start with the OSL dates. And in the lower fill, we got a date of 22,000 years from right here. And then in the upper fill, we got 16,000. So that was just perfect. But there was some disappointment because there may have been a greater contribution of uranium. It was measured by a different lab than what we originally had. When you have a greater concentration of the background uranium or probably anything else, and I'm sort of out of my realm here, but that would make the date younger. So taking into consideration this greater contribution of uranium, the date came out for the lower date only 13,000. And I think the date here in this middle gully fill was only 9,000. We still need to do work on this, but you know, everything costs so much money that you just can't keep going with stuff. Anyway, this is Don Monroe, who you saw in a picture previously with Al Goodyear and me, and Don is taking the background radiation measurements there. And here's David Lee, just about one of the nicest guys you'd ever want to know, and he's pointing to what might be a possible artifact down there in that lower deposit. Now I'm going to finish up here, and I'm going to say that these are sort of the large artifacts. You can tell from the scale, and like I say, I've got most of them with me. But they don't have any really wonderful shape or anything like that, but they are missing most of the geologic cortex, and they all have use wear. And to me, they're artifacts. And every time I think about these things and get these things out and look at them and talk about them, as much as I've tried to keep quiet about it because you don't want to make a fool of yourself, I still look at them. And by the way, I do consider myself a lithic technologist. I worked with the world's greatest lithic technologist way back in 1969, and I still think that they're worked, but they're not. They don't have any formal, any formal kind of shape or anything. I don't think that they arrived in the lower deposit by bioturbation or by pedoturbation, and that means either by animals moving them down or by some kind of vegetation moving them down, like roots or something. It's possible that they could have been moved a little bit, but you certainly couldn't take big artifacts, pieces of stone like that, and move them very far down. It just probably wasn't going to happen. Here's some of the little artifacts, and again, you can tell by the scale there that they're little. To me, these unquestionably have use wear on them. So if these specimens have no formal shape, no uniform flake removal, but they do have patterned use wear, and if they're artifacts, then how do we account for the differences in the extreme weathering, the typology technology, the subposition in the profile when compared to those from the sand stratum, without concluding that they're not older than Clovis. And so that's it. Thank you very much.
Is there general chronology for that whole area of deposits? Not necessarily the specific context in which you found the finds, but just overall?
Are you talking about the recent material or what I found, the old stuff?
Well, in terms of those general layers.
Oh, yeah, I think pretty much, yeah. You mean the stratigraphy?
Yes.
Yeah, well, I think so. But at that site, even though we had essentially the same stratigraphy, and you know, maybe we didn't go deep enough in some of the other places I excavated at that big, long site, that there could have been stuff other places also. Now, the Cinder Edwards site, some people may know that I also excavated earlier than the container site. And to this day, I'm sorry that I didn't realize what I might have found there, because I bet you that that also has an earlier component. It's same kind of situation. I'm just about the only person that's done any, you know, I mean, it's sort of sinkhole type topography is what it is, so. Yeah.
Dr. Purdy, in your heart, what date do you come up with?
Yeah, well, in my heart, I think people could have been in the Western Hemisphere 30,000 years ago. That has to do with the anthropology, the evolution of humans, their cultural achievements, and all of that. I don't think people could have been here much before 30,000 years ago. But you know, a lot of people might disagree with me, and we are occasionally finding things that look very, and I don't want to use the word Neanderthal, but the technology is what's called Mysterian, and it's called a Lavawa technique, and honest to goodness, that's what the Neanderthal people were doing. And we get it in the eastern United States. I have no idea if they have it in the western United States or not. But so, okay, what do I think the relationship might be between these old tools and Clovis, which would be, you know, a very, very sophisticated kind of technology. If the stuff is as old as we found, and this bothers me, there is no connection. It almost looks like if it's an old bunch of people that may not have even survived. And we get a break in that technology. I mean, if these things are artifacts, there is probably pretty close to a 10,000-year break. And I've puzzled over this myself. And that's why I'm willing to believe, despite the fact that I look at these and I cannot believe they're not artifacts, I'm still willing to believe that maybe Mother Nature, did it. I mean, maybe if you went to an old site where humans couldn't possibly have been there, and you looked around, you might be able to find some artifacts that look like that Mother Nature made. So,
have you been to the Topper site?
The Topper, yeah, many times.
Did he find similar things?
He is, but their deposits are so different than ours. Ours are so distinct, because it's he's got mostly a sand face, and if you just looked at it, you'd almost be looking like pure sand, unless you were familiar. They've been able to determine that there are some breaks in the stratigraphy at that site, but to the average person, if you just looked at the whole profile, it just looks like sand. Now, ours doesn't look like sand. You definitely are getting into something else when you get down to ours.
Have you found any other indications of human activity other than the tools?
That's the big problem. It's the dating problem, and that's why we did weathering, and that's why we did thermoluminescence, and that's why we're doing OSL. There is no vegetation, not even in the sand deposit. There is no vegetation. We didn't even get phytoliths, I think, and either did Al Goodyear at the Topper site. And now in the vicinity of the container site, there are some large late Pleistocene extinct animal deposits. And I think we actually, on the Edwards property that I was just mentioning a minute ago, there were some exposures of some animal bones, not where we were excavating, but on the property, so it wasn't too far away. But no, we just don't, that's just it. There isn't anything else. There isn't any, even in the top layer where we're getting the recognizable artifacts, which we know what the dates are, there's still no vegetation. There is no pottery. We found a little bit of pottery at one part of the site. I think people must have just come in and camped there or something. You just don't get that kind of preservation. Florida has a really bad problem that way with things being preserved.
Except for your wet sites.
And I got to tell you, that's why a lot of people interested in the Paleo-Indian and earlier period have started doing wet sites, because there, even though it might not be at the other sites, when you excavate a wet site, you're getting all of the material culture that is missing from your old sites.
Well, Dr. Purdy, some of the early forensic specialists seem to indicate that these pre-Clovis people may have been European rather than Siberian.
Okay. I've become an expert on this topic, so almost anything you mention about it, I'm going to be able to. The first thing, when they said that about the Kennewick Man, Kennewick Man in the first place is not that old. He's 9,000 or so, which is old, but it's not paleo. So he was probably early archaic. A guy that I actually happened to know about 50 years ago out at Washington State was the one that made that comment about he looked more Caucasian than he looked Oriental, and that got in the news, and he later sort of retracted that statement. But if you talk to the people that really study these early skeletal materials, you know what they're going to tell you? They're going to tell you that it was more like a generalized human. It wasn't Oriental, it wasn't Negroid, it wasn't anything. If anything, it came closer to looking like an Australoid, from Australia or something like that. And not because the Australoids got over here, but it was a stage of evolution of humankind where they went from a more generalized kind of human to a more specific racial type as you came up through time. So,
Other questions?
Well, you have a large area that's shown on the map there, you have various areas, 1, 2, 3, 4, 5. What makes you determine, how do you determine where to look?
yeah. Well, you see, that was it. We surveyed the whole area and tested. We did little test pits, and we did put in about 8 or 10 other excavation units around the whole site.
Do you look for bodies of water nearby, or
Well,
perhaps?
this was simple because it was a quarry site, and the stuff was just all over the place. And Container had been clearing the land to plant their trees, and for their timber company. And so all you had to do was go down to the bottom of that sand, and even in the sand, and they had stuff. You'd uproot a tree, and the base of the tree, the roots were just filled. In fact, I've got pictures of tree root excavation. So, and you were wanting to ask a question about the nanodiamonds. Yeah, another thing that's come up, and again, all of us in archaeology that are interested in this time period are grasping at straws. And a couple, 3, 4 years ago, a group of scientists, very reputable scientists, and I'm not going to go into any detail, but essentially said that a comet hit above the Earth, not the Earth itself, but exploded above the Earth, and that sprayed down all of this debris, caused forest fires, caused the demise of the late Pleistocene animals, I don't know how many genera, 50, 60 genera of animals, and caused the demise of the Clovis culture, and so on and so forth. And then about last February, another very reputable group of scientists said that was the biggest non-event that ever happened, that these kinds of little micro things are coming down all the time, and you shouldn't be surprised if you find them. But now there's a recent article, I think he's got it with him here, where Kennett, the prime, or the senior author on the paper, came out again, and he has some sort of pretty good documentation. If we do a site down near the old Vero site down near Vero Beach, we may ask that group of scientists to come in and take and check and see if we have nanodiamonds, because at that site you do have an abrupt disappearance of the animals, just cut off, and then you have a different deposit and you never get any more. So